job is to factor the numerator and the denominator, and before you cross anything out, make a note of the values of x that make the denominator equal to 0. Those are called the restrictions. This right here, restrictions on x, are the values of x that make the denominator 0. You're not allowed to plug in. These are not trinomials, so this is not a problem for the where we need to use the box method, the x game. What's the first step in factoring? Always? What is it? Whenever you're going to factor any polynomial, you always pull out the GCF, the common factor, or the greatest common factor. When you look at the top, what factors on the top?
3.
They have a 3 and an x in common. So let's pull out 3x times what's left after you pull out the 3x?
X plus 5.
What is it?
X plus 5.
You have an x and a 5. Now let's see if you understand why that is. 3x times x will give me 3x squared, and 3x times 5 will give me 15x. Do the same thing on the denominator. See what you get. So what's 2 and an x, and what's left in the parentheses?
X plus 5. 2
X
plus 5. No, x plus 5.
X plus 5, okay. So 2x times x is 2x squared. 2x times 5 is 10x. That works. Now, it is tempting to cancel things out right now, but before you do that, notice that I'm asking for restrictions. Your restrictions must come from the original denominator. So what you do is you ask yourself, all right, I need to set this equal to 0 for the restrictions, right? What that means, you don't have to write this on the test, you don't have to write restrictions. You just have to take the denominator, 2x times x plus 5, and set it equal to 0. So this is going to be 2x equals 0, or x plus 5 equals 0. If 2x is 0, what is the value of x? All right, this is one restricted value of x. X equals 0 is not allowed. Or, if x plus 5 equals 0, what's the other restricted value of x?
Negative 5.
All right? So you're going to say right here, x cannot equal 0, comma, negative 5. Those are called your restrictions. Now that you wrote them down, now go ahead and cross out anything that you see that you can cancel out. Can I cancel out the x plus 5?
Yeah.
Yeah, notice I'm not canceling out the 5 and then the x. The x plus 5 is a single factor here. That goes away. What about the x? Can I cancel out the x?
No.
Because they're being multiplied, you can. This is 3 times x plus 5. You couldn't cancel the 5 on its own because it's being added, but the factor x plus 5 is being multiplied by the other two factors here. And when you have multiplication, they cancel each other. So it's perfectly okay when you have 3 times x over 2 times x to say, well, what's the point of multiplying by x if I'm going to divide by x in the next step? So cancel that. And what are we left with?
2.
So here's your final answer. This is the way the answer would appear on your exam. You would say the answer is 3/2. That means no matter what x you put in here, if I tell you find me the value of this expression when x equals 17, guess what the answer is going to be? 3/2. You don't have to waste your time playing it. It's always going to simplify to 3/2. What about when x equals negative 157? You've got a negative 157 here, 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 and here. What's the answer going to be when you simplify it?
3/2.
3/2, absolutely. It's going to be 3/2.
Can you convert it into a mixed number?
You could, but you don't have to.
Okay.
It's perfectly okay to leave improper fractions. In algebra, we prefer them. Now, don't forget to write the restrictions on the variable. What did we say are the only exceptions? X cannot equal
0,
and it cannot equal
negative 5.
negative 5. So that's our answer. So you're going to have an expression that is simplified. Now, it's not always going to be a number. Sometimes it could be an expression, like what I gave you over here. You know, x squared, x minus 2x over x plus 1. So let me give you x plus 1 times x plus 1. You can write it as x plus 1 squared. I don't advise that in this class. So I'm assuming that you can do this now with the factor. X plus 1 times x plus 1. What about on the bottom?
X plus 1.
X plus 1.
X minus 3.
X minus 3. All right, so we have the factors. Now, before you cross things out, ask yourself, and you don't have to be doing this big process here. You can just look at this now and say, all right, what are the values of x that would make this 0? What value can I plug in here that would make this denominator 0?
Negative 1.
Negative 1. Negative 1 plus 1 is 0. What value of x would make this 0?
3.
3 minus 3 is 0. These are called the restrictions on x. Now, I just skipped a step here to show you that it's something that you can do, but by all means, right, since you're starting out, many of you have never seen this before. Just get rid of this.
Looks like it.
How is it 3 if it's positive? So 1 and 3.
Why is this a positive 3? Let's see that. Let's see, restrictions. Let me show you how I got these numbers now, showing you the word step by step. Restriction. So when you want to find the restrictions, what do? Copy the denominator and set it equal to 0. If x plus 1 times x minus 3 equals 0, right? That means that x plus 1 must be 0, or x minus 3 must equal 0.
No, but how did you get negative 3?
Oh, in the factoring? Oh, that's what they students gave me, but here, to do the factoring for this one, you would put this in a box. X squared, positive 3. So we need two numbers that multiply together gives me 3 times 1 is 3. And negative, oh wow, that's right, negative 2, I didn't check. I see. This was a typo on my behalf. I'm so sorry. This should have been a minus 3. Otherwise, it doesn't factor. You're right. This doesn't factor. The way I had it written down does not factor. This is a negative 3 right here. Thanks for pointing out. This is minus 3. That's what I meant.
So is that going to change the?
No, the answer was right. My question was inaccurate. It doesn't factor with a positive 3. I meant to put a negative. And now that gives me the negative 3 that I need right here, then we finish solving these equations by subtracting 1 from both sides, x equals negative 1, or adding 3 to both sides right here, x equals positive 3. These are the values that would make the denominator 0, so those are the values that I'm going to say. These are the restrictions. X cannot equal, that's the symbol we use for cannot equal. It cannot equal negative 1 or 3. And now cross out what you can. What can we cross out in this case?
X plus 1.
This x plus 1 and this x plus 1 are going to cross out?
Yes.
And what's our final answer? X plus 1 over?
Negative
X
3.
minus 3. Now, how come I'm not crossing the x's out right here, but over here I did?
Because you're adding or subtracting.
Over here, this is not multiplication, right? This is addition and subtraction. They don't cancel each other out over a division right here. We can do it here because this was multiplication. You're multiplying by x and then dividing by x. So they cancel each other. So your final answer in the exam, if this was a test question, you would say x plus 1.
And the restriction.
The restrictions, x cannot equal negative 1 or 3.
Yeah.
restrictions come from the